Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Hybrid ANFIS-PID MPPT Controller for a solar PV system with electric vehicle load. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the intelligent system that we have designed for power tracking technique in the solar PV systems. So this is basically the technique which is inspired from the artificial intelligence and machine learning that is utilized to track the maximum power and or to further equip the different systems. So in the domain of the solar power systems, we are developing this technique. Before moving to the technique details, let's talk about what we will cover into this video. In this video, we will initially talk about the application areas, whatever we have designed, where it can be realistically implemented. Then we will talk about the models that we have designed, how to execute them, what are the software requirements for them. Along with that, we will discuss about what are the current systems and the problems identified in them and how proposed system is handling those issues and what we have done into that. Finally, the experimental outcomes and the findings will be discussed. So let's talk about the application areas. So the system is specifically designed for the solar power energy extraction. So this is in the domain of the solar energy, because this is one of the recent technology and the power source which is used in not only in the industrial purposes, even at the normal human is also using for that. And in the domain of the electrical vehicles specifically, as it is the recent domain, and on daily basis the researchers are working in order to uh, charge the batteries fast from the solar and using the renewable resources and other sources also. So in the domain of the electrical cars and the solar operated cars, it is very much successful. So thirdly, in the domain of the grid connected PV system, where the power is being generated from the solar panels and further fed to the homes or the utility grids and all. So in that domain, this system is showing its advantages. Finally, in the domain of the renewable energy resources utilization, the solar is playing an important role. So in the domain of that renewable energy resource handling, the current developed system is very much effective. So now let's talk about what we have done and what exactly the code is. In order to run the code, the folder that we are going to give will be like this, in which there is a code folder in which all the codes and the files has been placed. So the whole system is being designed in the Simulink of the MATLAB, so you must have the MATLAB software along with you. The MATLAB version that I am using is R2019A, so you can use 2018 or 19, any of the two. In order to run it in the previous versions, you just need this model 2019A, so that you can export them to the previous versions, but I recommend to use the 2018 or the 19 only. So in order to run the code, you just need to go to the folder where the code has been placed and copy the path of the folder, then go to the MATLAB and just place the path and press enter. When we will press enter, you can see all the files are here in the system, out of which these SLX file, this and these three are the models that we have designed. And in order to run for the previous version, you just need to import it, then the file will be like this. So you can just delete these files, these are not important. I'm gonna just delete it. So the three models will be these three models. One is ANFIS MPPT resistive load, then a DC pump is connected at the output, and here the battery is connected at the output to get it in an effective way. So what exactly we have designed? So in order to run the model, you just need to open the file. When you will open the Simulink model, it will be opened in the Simulink of the MATLAB. Along with that, we do have this neuro fuzzy system design, which will be run at the initial stage when this model will be opened. So you can see it is taking some time because it is running this file. I will talk about this file later on. So as the file is opening, you can see these are the neurofuzzy system that is initialized before opening the model, which is having the two inputs and 49 of the rules and one of the output in the V reference model. So this is the overall model that is there. So when this model will run, that file will be executed, the model get trained, which will be further used in this to take the decision and to get the maximum output. So here you can see, here is the irradiance and the temperature input given to the solar panel, which helps in giving the PV's voltage and the PV current, which is further fed to the MPPT system, which is basically the controller system, which is generating the duty cycle in order to get the PWM. This PWM is given to the IGBT, to which the whole system is being given, and it is finally giving us the V output, which can be used for the certain loads. Here the load that we have attached is the resistive load. So this is the initial model that we have designed. So in this MPPT system, we have further implemented the whole scenario in which neurofuzzy is being implemented under this. So these are the processing of the data. You can follow the previous MPPT controllers. Those are used to generate the duty cycle. So here, in order to take the decision for generating the duty cycle, we are using the neurofuzzy system along with the PID, to which the output V reference voltage is given to the PID. So PID is not directly operating, so the decision of giving how much voltage must be given to the PID to generate the duty cycle is decisionable and is taken by the neurofuzzy. So we have mentioned the neurofuzzy file, that is FIS training 1, under this, which is basically get trained with the database that we have given to that, and on that behalf it is taking the decision that how much V reference should be taken out, and that will be fed to the PID. Now when from which where this particular variable is coming, so coming back to the MATLAB, here you can see when I was running the code here, FIS training 1 file has been generated. How it generate? This is the file which is called when it run, and these three of the figures was there, right? So when this code is executing, so this code is called during the opening of any of the three models, in which the initially the dataset is being created by us, where three of the inputs, two of the inputs are there, where is the change in the error, where is the error and the change in the error, right? So these two are deciding the output, that is the V reference voltage. So further, so the model that we have designed in the proposed method, let's talk about that. So to finally run it, after those files will be executed automatically, we just need to run the main model here, and then we just need to click on the run button. So when I'm clicking on the run button, it will execute the simulation. You can see the output at here in the scope, two different scopes, where the PV voltages and the extracted voltage from the proposed method has been shown in order to support the results that we are getting the better results in comparison to the existing system. So it will take some time to get executed because it is going to be simulated for so much longer period. So you can see it start processing. These are the duty cycle generated from the system, and this is the output voltage, which will increase as the system will increase simulating, right? So in the second scope, we are seeing the curves for the voltage, current, and the power extracted out from the system. So here in this scenario, it is just showing the resistive load. So I'm just stopping it from here, and let's talk about that what we have designed. So I'm just closing it. So in the existing systems, there are a number of MPPT systems, those who are working on the normal techniques like INFS. Then few of them are using PID based controllers, PI based controllers. P and O method was there for the MPPT. Even many of the people are also using fuzzy based models. So what we have introduced, that fuzzy is restricted with certain things like whatever the rules you have given, it can also only get the decision on those basis. If any of the condition that will arise in the scenario where the decision is to be taken by the model, then fuzzy is gonna take the random decision and can impact the outcome. So in order to handle that, there is a technology for the AI, that is neuro fuzzy, which is a combination of neural network and the fuzzy logics, in which the fuzzy system is also initiated, as well as few of the information is given, in which the neural network get trained with the patterns and capable to take the decision where the case is not already with them. So we have created this file. Along with that, we were also following one of the paper to analyze the scenario. This was the reference paper with us. So in this, what they have done, they have designed the system by using the PID controller for checking that how the DC motor is being moving and how the electrical vehicles battery get charged. So two of the cases we have analyzed, in which one of the DC motor speed is to be increased by giving more power, so that we can show that the maximum power is being extracted out from the system. In second scenario, the state of charge of the battery is being evaluated by applying the battery at the model end. So in the proposed system, initially the dataset for the three different two inputs and one output as a V reference has been generated, which is further created as a dataset, and the fuzzy file has been generated, to which the membership functions are set to be 7. So these are the this is the error when very less, medium, negative small, 0, positive, positive medium, positive big, right? So same in the change in the error. So these inputs will be fed to the controller that we have designed, and that we have our system get trained, and it will take ready to take the decision. That will be the V reference, which will be further fed to the PID controller to generate the duty cycle. So we need not to run it separately. Let's say I'm just clearing it, clear. So you can see there is no variables in the workspace. So whenever I'm the file I'm opening, one is the DC pump file is there, another one is EV file. Resistive I have already shown. Instead of the resistance, we have applied the DC pump and the EV battery to show that how it gets charged. So let's open the DC pump. So you can see when I'm opening it, it will execute the code that we have designed, and will create the variables and the model that is called under the category was FIS training one. So it will be generated and will be there in the workspace, which when model will be executed, will take it from the workspace and automatically proceed with the simulation. So let's wait it to be completed. So the code file is just opening, and it will run execute this file. You can see the files has been initiated, 1 2 and 3, and all the variables those are initialized from the designed system will be there in the workspace. So we can see the workspace. So you can, these are the new files generated, and this file will be further used in the model to take the decisions. So what changes we have made into this, instead of using the resistor load only, we have applied the DC motor. That DC motor further giving us the details of the speed in the RPM. So we are checking how which duty cycles we are achieving, and how the speed of the motor is getting increased if maximum power will be achieved by using our proposed method. So when I'm clicking here, you can see it will show us that what will be the speed of the motor as per the better power will be extracted out. So rest of the model is quite similar, only the changes that we made is like the load is changes to the motor, and we can representing the results in terms of the RPMs. So you can see it is increasing. Even the continuous curve can be seen in the scope here. When I'm clicking it, you can see as the duty cycles will be there, the speed of the motor is slightly changing, and it will go up to an extent. We can also set the graph by clicking here, it will be very specifically. So you can see every time when the duty cycle increases, the speed of the RPM is increasing. It means the proposed scheme of extracting the maximum power is achieving the better output voltage and the current, due to which the speed of the motor is getting increased with the rise in the simulation time. So it will take much time to get executed. So as we are restricted with the length of the video, so I'm just closing it here and stopping the simulation. When I'm stopping it, the second model I'm going to show you, that is basically the EV motor, EV. to which we have applied one of the battery at the output, and we are showing that what is the state of charge of the battery, that whether we are getting that much power with us to get the faster rate of the charging. So let's wait the model to get opened, then I will show you the results. So the main contribution is introducing the concept of neuro fuzzy, which basically an improved version of the fuzzy and the combination of neural and the fuzzy logic. Secondly, analyzing the proposed system with the DC pumps speed variation with the proposed models efficiency of extracting the power from the solar system. So that what we are doing. And thirdly, in the battery charging, we are checking that is the model effective enough to charge the battery at the faster rate when maximum power is there. So you can see it is showing us the SOC, state of charge, and this is the EV vehicle, means the battery which is getting charged from the output voltage received from here. So when I'm running here, so you can see it will show us the state of charge. So you just need to click on the run button and it will initially compile and then start executing. So you can see it started. So if we will talk about the output voltage, the curve can be seen here, as well as the SOC, state of the charge, can be seen at the output to represent that whether our system is effective enough to get the results that it is charging at the fast rate. So you can see the curve is increasing. So it will simulate for these two scenarios. So let's see the results directly, because it will take too much time to get execute the whole scenario. So we have written a paper for it, through which I am showing you the result directly. So this is the paper that I'm going to show, in which the results has been shown. So you can see the models that we have analyzed were giving us the state of charge like this here. By changing the time, the state of charges reaches to the 80%. And for the DC motor speed, the curve that we have analyzed are this, means by changing the irradiance, the maximum RPM speed we got with the basic model was this curve, and with the proposed methodology it was higher. So let's see the results directly, because we noted these values from the simulation, and for the comparison purpose we also plotted the results directly by putting these values. So you can see the curve of the proposed ANFIS based PID model is better in the case of the motor speed, because the maximum power is extracted out from the existing MPPT based models. So further modifications are still possible. For those information you can contact us directly. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.